The village of Zamora in Algeria. It is 1985. Midsummer. Hot, dry and dusty. Down in this village, 20 times every day, a truckload of heavy steel pipes is edged gently and skillfully through the narrow winding street. All are large diameter pipes, 24 meters long, and all are on their way to build up pipeline GZ3. Algeria's gas pipeline GZ3 now stretches for over 500 kilometers. It's the carrier for natural gas from the wells of Hassi R'Mel, deep in the desert, where gas has lain dormant for millions of years. Pumped through GZ3, the gas crosses a landscape of striking contrasts, up over the Atlas Mountains, under the salt marshes and plains of the north, then to the terminal on Algeria's Mediterranean coast for refining and shipment. NACAP was responsible for the northern section, from the coast to kilometer 295. The contrasts in the region are heightened by dramatic changes of climate. Winter rain begins to fill the dry wadis. It turns the salt marshes into swamps and transforms the arid plains of summer into lush pasture land. The orchards bear their crop of ripe oranges, and the plantations of olive trees are carpeted with bright yellow flowers. Under this varied landscape now lies Algeria's gas pipeline, GZ3. Gas resources come under Sonatrach, the state-owned energy company. Sonatrach was NACAP's client on this project, and cooperation was close and cordial, with monthly meetings at the IDRA office in Algiers. Back again to the summer of 1985. Every one of the total of 10,000 pipes passes through the pipe yards at Hillel. The helical welded steel pipes made in Algeria have been hauled from the factory at Annaba by SNTF, the Algerian National Rail Transport Company, double jointed by NACAP, and stockpiled. They're measured, checked and allocated to a certain section of the line. Then they're loaded for transportation. Some, close to the stockyard, have a journey of only a few kilometers. Others can travel up to 200 kilometers on highways, then on desert roads. Most trucks carry 3 pipes, some only 2, the heavier pipes for special sections with 19mm walls. Most have 12.7mm walls, but all are about 24 meters long and 42 inches diameter, making them bulky, cumbersome and difficult to maneuver. The success of the huge transport operation is a credit to the organization of SNTR, the National Road Transport Company, and to the skill of its drivers. But the villagers of Zamora have now seen hundreds of these loads, so few heads turn as they go by. Work goes on. The markets must flourish. Shopkeepers must bargain, as they do in 1,000 villages throughout Algeria. GZ3 is strung out and joined up from north to south. Here, going south and approaching the Atlas Mountains, trucks pass close to pipeline already completed. At places, the pipeline is left unjoined to permit hydraulic testing of sections later. Stringing the lengths of pipe, or joints as they're called, has reached the scrubland desert to the north of the Atlas Range. As the trucks come in from the highway, offloading of the heavy pipes is quick and efficient. This work is helped enormously by the use of vacuum lifts, now fully proven. This method was first used in this way by NACAP in their successful contract for 450 kilometers of 60-inch water pipes in Saudi Arabia. Later, the pipes will be welded into a continuous length above ground, then coated and wrapped and lowered into the excavated trench. The pipeline route, or right-of-way, is not straight, and it's far from level. Bends, both in the horizontal and vertical planes, must be allowed for. This bending machine exerts enormous hydraulic pressure to produce a precise curvature, predetermined by engineering survey. It works constantly and is moved along the pipeline as stringing continues south. The joints, laid out beside the open trench, now have the exact shape needed for that particular curve of the pipeline. At this stage of the construction program, NACAP was operating 3 base camps, each for 500 men. One was near the pipe stockyard, one close to the pipeline dockside terminal, and Camp 3 near the southern boundary of the contract. Here there was a specialized maintenance section, including training facilities. Camp 1 had an extensive prefabrication yard for producing special sections of pipe. Camp 1 was also the main administrative base and held the computer systems. NACAP realized the value of computer control of pipeline contracts on their huge Saudi Arabian project. Payroll, purchasing, stores and inventories are all computer controlled. But perhaps most important is the time and cost program run in relation to the field budget and known as a deviation program. This enables any activity to be immediately compared at any time to its budgeted time and cost, so that corrective action can be taken if needed. "180 cost centers are controlled on this deviation report system. A weekly summary of deviation, positive or negative, is computed and used in conjunction with the project's critical path system at weekly site meetings. Trench excavation along the right-of-way is completed ahead of pipe stringing. Temporary crossing places are made for use by local farmers and are then excavated immediately before pipe stringing. There are places where hard areas of rock require drilling, charging with dynamite, and blasting. The fragmented rock can easily and quickly be removed. The trench has now been excavated all along the right-of-way, and pipes ready for welding crews have been strung out beside it. Before welding, the joint ends have to be preheated by gas torches. This is the welding train. Set up tractor in front, stringer bead and hot pass, and fill and cap crews. Pipe is set up over the internal clamp and the ends spaced for welding. The stringer bead is made by 3 or 4 welders simultaneously, with the hot pass coming up behind, and later the X-ray check. Pipelines in a trench must rest on a smooth, level supporting surface. To make this base, sand is laid in the trench to a depth of not less than 12 centimeters. For this contract, NACAP bought production rights on suitable nearby sand pits. The sand was graded to eliminate stones and gravel. It was shipped in lorries and stockpiled along the right-of-way. Usually the sand base is put in right after trenching, but in some cases it must be done after the pipe has been welded. Bottom, sides and top of the pipe are padded. Coal tar is used for protective coating of the pipe. It arrives in barrels as solid material. It's chopped into pieces and later heated to 240 degrees Celsius. The line of machines moves on slowly from north to south. It comprises cradle tractors, cleaning and priming machines, graders, a further set of cradles, then the coating with coal tar and wrapping with fiberglass and reinforced felt. Then follows the lowering into the trench. Beneath the watchful eye of the regional guard, the pipe has been welded and laid, ready for backfilling. In NACAP's 220-kilometre part of GZ3, there are 9 block valve stations. These 42-inch ball valves could be used to halt the gas flow if damage or any other emergency occurred, or of course, for routine maintenance. The special pipe fittings have been fabricated in Camp 1. Spread along the 220-kilometre length, there are now pits for 6 huge anchor blocks, 1 set each side of the 2 PC stations and 2 at the terminal arrival. When filled with concrete, their purpose will be to stabilize the pipeline and to prevent movement. Once the pour of 300 cubic meters of concrete fill begins, it must continue day and night. Other work on the line starts early and finishes late. This is one of the last pipe loads, setting out for the southern end of the contract. At this southern end, the chain of heavy machines is approaching the steepest incline, the crossing of the Atlas Mountains. Tiaret Hill has a gradient of 40%. The tractor power has to be doubled to hold and to haul the heavy equipment. This is one of the most demanding and spectacular operations. It demands full power from every machine and full concentration from every man in the team of experienced pipeliners. These men have worked throughout the world on gas, water and oil lines in all conditions of climate and terrain. But scaling Tiaret Hill in the Atlas Mountains was one of their greatest achievements. A contract like this, spectacular as it appears in such a dramatic setting, is entirely dependent on the support of head offices. NACAP's support comes from 1,500 kilometers away, in the Netherlands. From there comes financial planning, logistics, key personnel, purchasing, and many other functions needed for backup of the construction team. This constant and reliable support enables NACAP to work in any part of the world, however remote or isolated. All underground piping must be wrapped and coated. Special sections must be done individually by hand. This is PS10 being coated before backfill. Material for the backfill must be free of rock and sharp stones. For this reason, clean topsoil is brought in by truck and carefully placed in the trench over the coated pipe. This is the operation at terminal arrival. All the pipe has been completed, but now the winter rains set in, turning the right-of-way in some areas into soft mud, creating difficult, almost impossible conditions for men, machines and vehicles. In NACAP's section of GZ3, there are two compressor stations, SC4 and SC5. At each of these, NACAP built a scraper station. At these points, gas can be fed into the stations for pressure boosting, or can bypass them if required. As each section of the line is completed, it's hydrostatically tested. There were 66 test heads made of heavy wall pipe, each of which contains 3 separate scraper units, or pigs, some, like this, with gauging plates. The test heads, fabricated in Camp 1, are transported to the section where required. They're lowered into place and welded to the section to be tested. Water for the hydrostatic test comes from one source, the Wed Mina, through the cooperation of the Algerian Ministry of Hydraulics. The muddy river water had to be settled out in a separate reservoir before being pumped into the line. The pumped water pushes the first of 3 scrapers along the length of the test section to the far end test head. Air is vented off ahead of the scraper until the section is free of air and full of water. The process is repeated for each section. After a section is filled, the line is stabilized for 72 hours. Then the pressure test starts and runs for a further 48 hours. During this time, pressures and temperatures are constantly recorded and calculations made to verify the tightness of the line. When hydrostatic tests are finished, the section is dewatered. The test head is taken off and the pipe ends brought together ready for cutting, beveling and tie-in welding. These tie-ins cannot be hydro-tested, and to guarantee their integrity, a special welding procedure is used. This is the last of the tie-ins, which completes NACAP's line from kilometre 295 to the coast. All the tie-in welds are wrapped and then backfilled. For security, all line installations are fenced. This work following completion of each station. A painting crew works on above-ground sections as each area is completed, and another crew lays gravel. This is a PS or block valve station, fenced, painted, and with the surface gravel laid. The 2 scraper stations, PC4 and 5, are intended to separate the line at compression stations to allow launching and receiving the cleaning pigs. The pipes must be absolutely dry before they can be gassed up. On long pipe runs with no intricate fittings, This drying is done by a vacuum process. Electrically powered liquid ring seal pumps extract air and water which has been vaporized by lowering internal pipe pressure to 2.6 millibars. At scraper stations and at the terminal, air drying is used. Hydroscopic crystals absorb the water from compressed air before it's pumped through the installation, where, at a dew point of minus 50 degrees C, all remaining water will be picked up. At the terminal, as at the scraper stations, the line ends at a scraper trap. Then it branches off to a header, which will let Sonatrach interconnect several lines if needed. From there, the gas passes through filter separators to extract any foreign material before it passes to the flow control valves. They take gas at the line pressure of 65 bars and pass it on at the flow rate and the pressure required by the plant. Finally, the gas is measured in metering runs before going to the LNG process area. The whole of the terminal is maintained by computers in a central control room. The client's engineers, on a visit just before completion, seem justifiably pleased. They're receiving and will operate a well-built project, reflecting up-to-date technology, both in pipeline and station construction. GZ3 Northern Section was another internationally known project, completed to specification at the contract price and on time by NACAP, the Netherlands.